for 2019. We've had 4 different seminars during the year, one on sustainable packaging, one on pulp, super pulp, and one on water. And today we are going to listen to digitalization. That's our theme for today. And we're so happy to see both the crowd that's here, and you're all very welcome on the net as well. So without further ado, I'd like to present the first speaker, which is Mikael Rudin from ABB. And you're working with digital strategy and architecture. Couldn't be better. I'm really happy to have you here because we are working a lot with ABB. We have been working with ABB for a long time. And you have an intriguing title, Why and How We Digitalize the Future Industrial Landscape. I'm eager to hear what you have to say, Mikael. So the floor is yours.
Thank you, Pia. So, thank you very much for inviting me here. I think it's a privilege to be able to talk a little bit about this interesting topic I've been working with for some time. As we said, I'm Mikael Rudin. I work with digital strategy and architecture in ABB. And what I do is really to try to see where are we going with digitalization. And I will give you a little bit of a try to give an understanding of how we think about the industry in the future. And also how we think about what we need to do to actually raise productivity in the industry. Some years ago, we started to think a little bit about why do we digitize? I have been working in digitalization for more than 30 years. And like 10 years ago, we started to try to see, when we saw all these things coming, try to see what is really going to be our mission in the future. We've been working with automation systems for a long time, but now I think it's time to take a little bit a broader perspective of what is really digitalization. What do you need to do to actually raise productivity? Because that's productivity and quality is basically the reason for digitalization. And if you look at an industry and you try to be the most productive industry in the world, what do you really need to deal with? And what we found out was that really what it's all about is to get your people, equipment, and systems to collaborate. That's as simple as that to get productivity. The better they collaborate, the better your productivity is. Of course, we don't solve the problem that you have to have the right product for the market, but really productivity is all about people, systems, and equipment collaboration. And if you look at the result of the last industrial revolution, then you can see that this is really the result. You have islands of automation, you have islands of systems, you have islands of expertise. And these islands are working in the companies today, trying to solve the problem of raising productivity. And what we have seen is that what you need to get a higher level of productivity is that you need to break down these islands. To do that, you need something that connects them, so that you connect all the islands of equipment, but also the islands of systems together, so that you get one seamless environment where everything can collaborate. And then you need to give the people that works in your plant the possibility to interact with all these systems, information, and equipment. And by that, you raise the level of productivity. And this is really good when you now go into the next generation. Try to know what is our goals with Industry 4.0, because this is what we believe is the goal with Industry 4.0 and beyond. You need to get the collaboration to a higher level, and that will continuously increase as we see in the future. The collaboration is the goal with whatever you do when it comes to digitalization. And then when you then take on the challenges that we see, with having a situation that we get all these new ideas of what is it that we really need to do. You need to look at this from the perspective of how do we actually improve collaboration. And when you do that, you can look at that in several ways. One way is to see equipment to equipment collaboration. Does this initiative actually help in that? Or does it help people to people collaboration? Or does it help systems to systems collaboration? Or does it help equipment to people or system to people or system to equipment collaboration? If it doesn't help in any of these dimensions, then you should think twice before you get started with your digitalization journey. And I think that there's a lot of initiatives taken in the industry today that really doesn't go in any of these directions. It's just sort of trying to take some of the technologies and go with them. If you then take this to another angle and you go in and you try to see what is our company's strengths, then you can go in, you can make some investigations. How good are we in all these dimensions? And you plot them. Then you can see where do we have a strength and where do we have a weakness. What you can do, you can compare yourself with different companies and see, okay, compare with others in my business. How are we doing? And where are we weak and where are we strong? And based on that, you can start taking decisions of where should we actually go first. And this is very important now when you get all these new technologies and all these new suggestions for sales, from salespeople, from research, from everywhere, to try to say, okay, go with this, go with this, go with this. Try to figure out what should really be our goal. If you look at these new technologies, and you also have this new in the Industry 4.0 initiative that was started off in Germany, where they say that, okay, the thing with Industry 4.0 is that you get this kind of change in the industry, and they talk about it on a high level like this, that you go from a situation that you see here where you have the automation pyramid, and they say that will disappear in the future. What does that really mean? Well, Industry 3.0, then you have this hardware-based structure. What that means is that if I have a motor like the one in the bottom here, and I would like to raise the power of the motor, so I would like to have extra horsepower in the motor, then the only way in Industry 3.0 is to buy a new motor and install it. But if we go for the Industry 4.0, then you can actually get more horsepower without installing a new motor. I will come to how in a short while. The other thing they are talking about is that these layers will go away. Because if this motor is going to talk to my enterprise system here, it needs to go through a lot of layers, and all these layers have to sort of basically support the standards that is needed for me to talk and maybe tell my maintenance system or my purchase system that I need a new bearing in the motor. And it's very cumbersome to get this communication to work. These are things that will change in Industry 4.0. Then everything should be able to talk to everything without borders. So that it should be enough to implement the functionality in here and here to actually talk between the systems. So it will be much more efficient. And you also will have a situation where if I need more horsepower to the motor, well, the only thing that will happen is that I will download the horsepower, just like what you do in a modern Scania truck today. You press a button in the truck and you get sort of the new settings for your motor and you get the extra horsepower. You don't have to exchange the motor. And that is the way we think about how things will work in the future. And of course, this is also a big benefit for the Scania truck manufacturers. They can have the same motor and really get a lot of different levels of horsepower with the same motor. So it's less cost because you don't have to have so many models, and you get the same revenue basically. So it's an interesting finding. There is a lot of other things going on, like the talks about digital twins and IoT. This is the typical way to talk about that, is that basically you have the physical device. You should have some kind of software model of the same device in the software environment. Typically, you talk about that as in the cloud. And then you have an app from which you can operate this device. That's what you get when you buy one of your smart lamps at home. But this is also what you will get in the future, more and more in the industry as we see it. But one of the problems in the industry is that, well, you have the one app for everything that you buy. Certainly when you buy it from different vendors, you get another app. It's cumbersome when you have 100,000 pieces of equipment in a plant. It will be very, very hard to actually operate the plant. So, but why do everyone now start to make these IoT products? Why are we going for that? Why do you think Philips is making smart lamps? Typically, you talk about several levels of progress when you build an IoT product. You have the smart lamp. The first level is what you talk about as monitoring functions. That means that you in your app can actually monitor what is going on. Is the lamp on or off? Next level is when you can control it. You can switch the lamp on and off from your app or switch colors. Next level is optimization, where you can tell the lamp that, okay, you should, when it's 8 o'clock in the evening, you turn on, 8 o'clock in the morning, you turn off. This sort of optimization. But what everybody is working on is to try to get the autonomous lamp. But why do we do that? Why do Philips spend a lot of money on making smart lamps? Well, typically what you want to do when you have a product is that you want to sell it. And what they see is that gives them increased competitiveness. They really are able to sell lamps also in the future if they are smart. And then you can, if you think about that as a reason to make things smart, make your products smart, then you can understand that this is going to happen everywhere. There's no one that want to manufacture a product that won't sell. So this is really a strong force on the market that will bring every product, every piece of equipment will be smart in the future. Otherwise, you will not be able to sell it. And a very good example of that is actually the car industry, where car manufacturers, everyone is trying to make the cars smart. But not only the car manufacturers, also other companies like Apple, Google, all of these companies that knows what the technology to make smart things is all about. That means software. They are also entering this market because they think we are good in technology that is needed. So this simple thing to build a car can't be that hard compared with the technology they have to work with. But the real reason why you do this is you would like to be the one that sells all the cars, because the one that creates the autonomous car believe that, okay, then we will take the car market. And it's a big market, so that's why everybody is interested. But if you think about things like this, and you look at an industrial plant like this paper mill, then you will understand that, well, all the equipment in the paper mill will probably also be smart. So the future industrial landscape will look somewhat like this. You will have this kind of IoT. This is an example from a Swedish company that makes IoT X-rays. Basically, they take an X-ray photo of the incoming wooden chips, and then out of that they can analyze humidity, contamination, etc., in these incoming chips, and they can actually go back to the supplier and tell them that, okay, you didn't really get us the quality that we bought. We will get money back, but they can also use it to actually control their plant depending on the quality of the incoming chips. Another feature of this system is that it actually learns from other installations. So when an X-ray in one place learns that this is what copper looks like when it comes in with a wooden chip, then you will actually overhear this, so the other pieces of equipment will be even smarter. So they can also recognize that now we have some contamination with copper coming in for some reason. So it's a way to make it smarter. So you really need to connect the equipment to the cloud to be able to learn from other pieces of equipment with other vendors or with other of your customers. So this is why we believe this is the way it will look all over the place in a plant. You will have this kind of smart equipment. And of course, when you have this kind of smart equipment that is built, really purpose-built for this function only, you will still have this collaboration problem to solve when it comes to manufacturing paper. So this is good insight in what are the things we need to work on in the future. If you then take this and look at what are the means we have for bringing collaboration today, and how do they actually solve the problem? If you look at the PLC, what kind of collaboration is the PLC working with? Basically, the PLC is working in this area. So it's basically trying to get pieces of equipment to collaborate, work together. You have a control loop to get the flow to be stable, a pump and a valve and a sensor collaborating to get a stable flow. If you take another example, a DCS controller, it really has a little bit more capability. It typically is a little bit more open to connect to other systems. You take a SCADA HMI. What does it work with? Which kind of collaboration? Well, basically, it's to present what is going on in the equipment to the people. So it helps people to understand the equipment. It collaborates with the equipment. A DCS, well, it takes a little bit bigger piece. And if you see here, you can see that if you think about the price on the market, it's interesting. The area that you cover here seems to sort of be a reason for paying more from customers. They pay more for it. They really pay for the area you cover. And why is that? Because they need this collaboration. Collaboration is what they really buy. So it's a way to figure out what are the things that people really need or customers in the industry need from, you could say, digitalization. These are just some products that we have used for digitalization throughout this, well, 20, 30 years. We have been working on this. To take the next and say an extended automation system, which is what we have in the 800XA, it takes a little bit bigger piece of the puzzle. We also have started to work with how do you design the control room to be able to have many people working there and collaborating in a better way. That's why we get a little bit extra functionality, extra points in this area. We also have some, to say, furniture that is built for collaboration, where several people can interact with each other. We have what we call a collaboration table. And that's why we get some points in this area. But we also have a way to integrate different systems so that you get them all in one environment. So that's why we talk about these parts. If you then take a look at the new things coming on the market, the IoT systems, where are they working? Well, at the moment, they are a little bit narrow. They are working in this area. But of course, as you saw in the picture before, it'll be IoT systems all over the place. So they need to widen the scope if they want to be suppliers in the industry, so that they can collaborate in a better way. What they aim for now is to get people to understand much better. You get a much richer environment about exactly the piece of equipment you're working with in that IoT system. But other pieces of equipment is somewhat not of interest today. But of course, they will get into this situation. If you look at an MES system, well, that's basically not working so much with the equipment, but it's working with getting the information from other systems and taking that information and try to get people to understand what they should be doing to manufacture the product, but also to sort of give some input to the equipment so that it gets set points, etc., to run the manufacturing that is needed. Okay, but basically this has been a situation for a pretty long time in the industry, that we have been looking for improving collaboration. If we look at the equipment and you think about the systems that you have in the industry, you can see that there is a lot of different systems just having digital twins of a motor. You have your maintenance system where you have information about the motor. You have your purchasing system with information. You have an electrical drawing. You have your control system. All these are typically systems that have different pieces of information, and they all try to have a digital twin that is consistent with what is actually happening in the plant. Interesting today, and the result of these islands of expertise, islands of automation, islands of systems, is that different people work with different systems. And if we look at this more in, so to say, or in real terms, you can say you have a sensor and it has maybe a simulation model. It has in the control system, in the PLC or the controller, you have a very good digital twin, which is maybe on the millisecond level updated with what is actually happening in the plant. But as we said, there is a lot of systems that has information. One example that we tend to forget when we talk about digital twins is the video surveillance system. When you have a camera that looks at a piece of equipment, inside the camera system you have a very nice digital twin of what is going on. So it's a lot of these digital twins spread out in systems in every industry today, and in every plant you have a lot of systems with digital twins spread around. And it doesn't matter if it's single pieces of equipment or composites of equipment. It's the same situation. A lot of pieces of information which is really trying to build an image from a certain perspective what is going on. Industry 4.0 are also talking about that. And now they've started to talk about that as you go through the life cycle of a product, it starts with you have the requirement for the product, and you have the definition of the product, you manufacture the product, but then you put it out in the plant, and all the way here you actually increase the amount of information that is available in systems about the product. And when you do that, in the end here you can see that you get pieces of information in different systems, so you get the composite product which really have information in a lot of places, or at least in a lot of systems. And the challenge now is to get access to this information, and that's where you talk about this asset administration shell. It should be a way to, if you get to that, you can get to all the pieces of information that is relevant for this product. In ABB, we have, as I said, worked with this kind of problem for a quite long time. And we have figured out that it's a good idea to actually have this kind of container for this kind of information. So if you have work with our systems that we have today, we have sort of get a head start on building this kind of infrastructure that is needed to actually create this collaboration, because we believe that if everybody have the same picture and very easy access to these systems, you can really get to increase your productivity. So what we have is a possibility for local systems that you have in your plant. You can put them in the equipment, basically, or in the digital twin container of the systems, of the thing that you have out in the plant, the equipment you have in the plant. Just as they say in Industry 4.0 that the goal of Industry 4.0 is. You can already do that today, but just for local things and not for the IoT systems coming. But it's interesting. And really what we have done also is that we have put this into a situation so we can build a model, an information model of the plant, which is the sum of all the models in the different systems. And this is what we use then to get people, systems, and equipment to collaborate in the best possible way. So, if you already have this, well, what does it bring you when it comes to productivity? This is a plot of one of our customers that is really having a very big strategic focus on making every piece of equipment in their plant smart in the way we have actually sold to them. What happens is that they basically, it's the Aitik mine in Boliden, they are now 10% more productive than the second best mine in the world. So they produce 10% more copper per man hour compared with the second best. But it's interesting to know that the copper that they dig out has lower level of copper in it than any of the others. So the other ones, the yellow ones here, are the other mines in the world that are open pit mining. But they have less copper in the ore that they dig out than all of them. But still they get 10% more copper out of the plant per man hour. So it really gives you a big benefit to go for this kind of digitalization. So what they have done is that they have taken all their systems and plugged them in to make the equipment smart. What is happening now is we take the next step. Now we have worked with on-prem systems, local systems in the site. The next thing is systems in the cloud, systems out on the internet, systems within the manufacturings, the product makers systems, etc. So what the next thing is that we can actually bring them in to make the equipment even smarter. Of course, that will also improve the level of productivity. So we will get really the industry 4.0 will be when all the systems that has ever been involved in your product will be connected into one seamless environment where they just collaborate and bring the most out of the product to the user. So this is how we see the future of the industry when it comes to how will systems be built and how will products get smart in the future. So the future of a plant is that you will have a lot of IoT systems, but you also will have, and one of the enabling technologies that people are talking a lot about today is the 5G. Why is 5G so important? Because then that's the only way you can build a piece of equipment here without involving the plant owner to get connected to the cloud. So you can't really make the equipment as smart as you would like to without being able to connect it to the cloud, without trying to tell your customer that they have to deal with all this networking setup and so on. So 5G is really an enabler for these smart equipment and smart products. That's why it's so really so important to get 5G out there, because then you can start building smart products and smart equipment. So what will happen is that you will have the 5G, and that will actually connect all the products to the cloud. And of course, when you get the product, you will get full functionality immediately. Because it's connected to the cloud, you can utilize also the functions in the cloud. But of course, when you buy your product, you will get the sort of local operation possibilities. So you can run the product as is with local panels, but you will always have full functionality. Next thing is that the manufacturers would like to sell the product as a service. And when they do, they also need to operate the product. So what will happen is that the manufacturer will have their own control rooms where they will control the whole fleet of their products and make their products actually learn as we go and learn from other product installations to be the best on the market. And then, of course, you need to collaborate. So you will have this IoT collaboration systems that makes one product collaborate with the other, but it has to take the scope of all the different functions. So you have to collaborate on the local level, but you have to also collaborate on the cloud level with functionalities in the cloud. So this is really the view of the future industrial landscape that we are actually going to get to in 10, 20, 25 years or something like that. And the collaboration doesn't stop within company borders. We will go over company borders. We will have the same kind of collaboration because it's all networked, so it's no problem. It's just to solve the technical issues. We're doing that in a safe way. But the thing we are after is to improve the collaboration between people, systems, and equipment. So with that, thank you very much.
Thank you. We want. I'm just no. Please, you please stand there. I just wanted to. I need to get this first. I think there are some questions maybe from the audience. Questions? Yes. Closely.
Yeah. There's one question, but there's also not related to the details of the connectivity.
Yeah.
My observation, when you have different commercial partners collaborating in the traditional business model today, you normally end up with the strongest player setting the rules of the game.
Yeah.
And quite often sort of keeping information secret to have a benefit of the this model sort of assumes as it opens up for more or less information flow.
Yeah.
Needs to be management of the work, I guess.
Yes, yeah.
Sort of losing that.
Because I think one of the hindrance that we see today is that, exactly as you say, all the vendors that is trying to build IoT systems, they try to be the only one, and everybody else should connect into their system. But I mean, the open market doesn't work like that. You have to build an infrastructure where you can freely collaborate and cooperate and compete. So you have to have a competitive landscape to actually bring the best out of all products. You can't have a situation where I connect my product into an ecosystem and then I'm really dependent on the one that built the ecosystem to give me the possibility to build the best product. Yeah.
We had another question over there.
Hi, very interesting lecture, thank you. I was really interested, I mean, I'm listening a lot about IoT and cloud. So how and where do you see that machine learning or any other sort of AI technology comes into harmonizing?
Well, in every IoT product, there will be machine learning. And in many, you could say, different systems involved in every product, there will be machine learning. So it will be all over the place and multiple places. Today, I think it's a little bit like this, that you try to build one ecosystem and build it in that ecosystem, but it will be, every product will utilize machine learning and AI to actually get to be the best product in the world.
And so, just one quick follow-up question. So how do you avoid sub-optimization and you ensure that the entire ecosystem somehow manages to get there?
Yeah, I think that the market forces will bring us right in the right way, because the winner, the product that will sell, is the best one, and that is really what will actually solve most of the problems. Really, if you have a competitive market, the one that is most efficient to produce smart products will actually get the biggest piece of the market.
I think I was going to ask if there were any questions from the net, and as there aren't, and she's doing this, I can ask you one thing. One thing that always bugs me when this was the best picture of 5G and Industry 4, right, that I've seen actually. It was very comprehensive. So I have a problem understanding how in the world we should have enough energy to support all of this. When everything gets connected, when everything gets electric.
Yeah, I mean.
Are you thinking about those things?
Yes, of course. No.
Oh, you are, okay.
No, but somewhat I think that one of the things that is going on is that you're actually moving. What will happen is that if you build smart products that is always connected, the functionality that you have building smart products today or previously, that was all about putting in a big processor as possible in the product itself locally. And that is very energy consuming compared with running all the functionality in the cloud. So I think the trend is that less functionality built in and more functionality in the cloud. Of course, that has really to do with that you really have to get the communication working. But the more you put in the cloud, the better you'll get when it comes to energy consumption.
Okay.
So it's a way to make things more efficient. But of course, communication is very important part, and that's why 5G, all the concepts in 5G is so important.
Great. Thank you once again, Mikael. And we are actually, yes, you may give him. and I hope you will stay for a while.
Yeah.
Good. Because now we are getting into our world. We're going into paper making, and Peter Hansen, who is working as a research engineer or researcher here at RISE Bioeconomy, and you're going to talk about digitalization in paper making. How do you walk the talk?
Yes.
So the floor is yours.
Thank you.
It's all here.
Yeah. About digitalization, I got a note yesterday saying if you have notes and you want to use them, you have to print them out. And of course, our printer didn't work.
I have a solution.
You have a solution?
Yes.
Okay, then, we had a talk here about digitalization and collaboration, and that is true. And collaboration doesn't happen over a day, it's a process. Digitalization is you start somewhere and you want to go somewhere. And actually, this is a picture here of our pilot machine here in Stockholm. And you can see people walking here along. So I thought this was a very good illustration. Walk the talk. So what about paper making at the RISE Bioeconomy? Well, you could look at it like this. We have a traditional path and we have a more explorational path. And the traditional one, it goes, well, you're using paper chemistry, stock preparation, forming section in the paper machine in order to do more competitive paper products. And supporting the traditional paper making industry by that. But then we also have this more explorational part where we look at the media themselves. What if you use the traditional paper making equipment to do new things, like very stretchable paper or something like that. Of course, we can do this here because we try to scale up from the laboratory level to a more with a pilot scale to demonstrate the possibilities here. And we have this Phoenix or our pilot park and different test beds associated with this. And it provides a kind of enabler for this. And having that infrastructure, of course, we could do. It contains sensors, control systems, people working with this, and so on. So we may apply some kind of digitalization process connected to this as well. Which means that we, in that way, we can demonstrate new ways of working and go into what I call here the data coordination, which is this, of course, calibration using information. I will talk more about that during this presentation. Before I do that, let's say something about digitalization. Actually, I think the English is better here because they divide between digitalization and digitization, which is then making data available in a digital form, like measurements or documents, images, and get them up and in a digital form. Of course, then the second part of digitalization, the second pillar, is then to make something new use of it. And here we come with this big data, machine learning, try to make predictions or and then turn that into customer services as we heard in the last previous presentations. And of course, the enabler here, as we heard, is the cloud. Make things available so that we, in that way, can make new business models and do this coordination or collaboration. And one example or one way we are doing that here at RISE Bioeconomy is to work in different projects. This is one project, Salty project, which is a testbed project financed by Vinnova through this PIA. It is a connection of testbeds for the process industry. And there is a network around this also with different stakeholders. Someone has needs and someone provides solutions, and get them together and work together. And in such way create this kind of ecosystems where we can have new ideas of products and test them and get them faster into use. And thus enabling, this becomes enabling space for innovation. It could look like something like this. We talked about islands, how to get islands working together, connecting things and make it available such that we can test and bring up the solution for the needs. And it could be physical test beds or more virtual or tools to collaborate and communicate. And here we have our pilot machine as one example of the pieces in this puzzle. So if we have this kind of environment, what to do? Well, there are many opportunities or challenges. They usually come together, which you could address. And I picked out two, which I find very interesting personally. You see this guy? I believe all of you have seen this. Young people just absorbed into an iPad or a mobile phone or something. This guy is playing Pokemon Go. And I believe this is saying something about our future process operator as well. They expect immediate feedback on what they're doing. They're used to communicate through this kind of, not Facebook, but social media and have a huge network with people everywhere, helping each other, talking each other. My daughter, she has two mobiles, talking with her friends in one and playing on the other, for example. And I believe today, when I wrote this, I thought, well, this must be then in the future some support of self-learning, or no, that's not a good word, and some kind of teaching environment for the operators. Then I come up with this tutoring that you kind of help each other, coach each other in order to make things better. And I believe that is how you then, in the future, will promote development competence, how you, this knowledge exchange will be a very important part for the future operators. But what's the picture today? Well, we have in the industry, it's quite based on regulations and documents and how to handle that. It might come from, of course, security reasons, but also that's the tradition we have. We do something, write it up, and put it in a binder or something like that. Of course, that now is digital, or we are working with documentation in digital tools. But we are not. There's not that many who can do this or are available to do this. Well, many things to attend out in the industry. So to update information becomes, or might be postponed or also absent in some times. And of course, then if you are in that situation, it's even less time to analyze what you have there in your system, if you don't do it automatically or somehow. So you have solutions, you have documented solutions, but you don't really aware about it, which of course then makes it more difficult for knowledge transfer, because you have to experience things in order to learn them. And so there's no really systematic process in knowledge transfer. And what's happening is that you pair up experienced people with newly employed for them to learn how to do things, how to operate the process. So what could the future bring here? Well, I think this tutoring process operation would be one thing, where we have, for example, in this case, we have tested augmented reality here at FEX. And by that, we can overlay information that are linked to an object while doing things, while working with things. You can have a communication that supports your acting remotely for experts in other countries or with a colleague somewhere else in the mill. And you may interact with the instructions, and by that also become some kind of automated documentation of what you have been doing with sequence and what effect did it have. So in that sense, you get this immediate feedback on what you're doing. And you can compare that with what has been done before in order to see, was this better or worse? Have I performed good or not? And that will be a force for you to do better. This kind of tutoring operation. Perhaps even more visionary opportunity with digitalization is what I call here the data-driven coordination. We had Mikael from ABB talking about what you can do in a mill. And they ended that, of course, that is not enough. You have to collaborate between different kind of factories and so on as well. And that is what this is about, that you have information and not just digital twin of the mill or a factory, but you connect it to what you're doing as well, to connect it to the material you're producing. So that you can combine information with the material and package that to your customer, so they can be doing their process even more efficient. So you cooperate in the value chain in that sense. For doing that, you have to classify the functionality of your product, not just sell it by weight or thickness or something like that, but how it acts in the next phase in the value chain. And this digital twin then has to be linked. You need to know where the products are in the converting process in the next step in order to bring up the information and utilize it. So what you are coming up to here is that you use the solution and turning data into new ways of adding services, describing functionality. I'm not selling a paper, I'm selling you a solution for making your boxes even better. So you add not just to the product, you add also services, and that will become then a possible new way for revenue for the paper making companies, converting companies, and so on. So this is, if this is a vision, we're starting to walk this path. I mean, this won't happen every day. It's a process, and we started this, and this is an example here in the project Obapo, also financed by Vinnova, where we use information available in a min. The problem there is that when you do the quality measurements for the paper produced, it's very little part of the paper that you actually characterize. But we expand it. We use an IR camera to get a map, and then we expand the information from the quality system to cover the whole produced product. And by that, we can then use this map of the product as a starting point for our digital twin of the material that are produced. And then, of course, synchronize it with when was it produced in the machine, and you can build this package of information. So this digital twin of your paper, how it's made, you can use that together with the physical products in the value chain. And then you combine the product data and the process data and do machine learning for different industries in the value chains to cooperate with each other. So instead of making the strongest paper at a certain rate, you can make it more, you can adapt so that you produce a paper that is easily converted by a customer. And the customer on their side, they could use information in order to produce or to do this converting even more efficiently. And I believe this is a feed forward, but also feed backwards. I think that is important, that information goes in both directions. So the company here, they cooperate in order to help each other to make their products better. 1 + 1 becomes 3, or at least 2.5. This is examples on how we here could use paper making facilities, or the Phoenix structure we have here at RISE. We can use our pilot machine. We can take up the information, data on how the machine was run. We can use information on how it was performed, what kind of activities the operator did during this process. We can use characterization, this mapping of the material, and synchronize it with the production process, and combine that and package in order to test how will that product convert. How can the information from the making process be combined with the information from the converting process, so that we manage the data, structure it for availability and collaboration, put in the operational support into this, and make some kind of coordinated production through the value chain, and demonstrate how this could be done piece by piece. So that is the first step on the process here, the digitalization process.
Thank you very much. So, are there any questions for Peter? Walk the talk. How far are we from walking the talk? I mean, this is, you're talking about the paper industry, and you're talking about the pilot machine we have here. And when I think about what Mikael talked about with 5G and the cloud and all of that, it really expands your imagination of what you could do, doesn't it?
Yeah, and you have to walk the talk. You have to take it step by step, of course.
Yeah.
And doing that, you have to have the courage to start walking as well. And I believe that is one of our things we can do here, to show what is possible and show how different ways of doing it, to inspire the industry to start this walking.
But I have this idea that the industry is kind of hesitant in moving into this area, or I mean, the industry that we're when we talk about paper making. Is that true, Mikael? Is that true?
Yeah, I would say that in general, yes, but we have some interesting customers coming along and wanting to run everything in the cloud and things like that. So it's coming there.
Yeah, I'm agreeing with you as well. The last years, I think people have more opened up and they realize that, well, working in the cloud, exchange information with each other is needed, required for them not to develop and to continually be competitive. If you want to sell, you need to have smart cars to sell them, then maybe you should sell paper by functionality for the customers rather than by strength and weight.
Yeah. Yeah. You should take care of that. Yeah. Okay.
Can I ask a question?
Absolutely. Yes, please. You have it.
Thank you. So it's interesting to see how you're painting up a picture of all these different technologies that are enabling us to make sort of transformation. But sort of, where would you start? If you just say, I'm from a small company, and for us, we have these islands, we have these different systems. I'm sure many others have the same situation. how do you build that business case? What is do you have any experience or any comments to how do other companies start their journey? What is their sort of main driving factor?
Yes, the main driving factor is economy, of course. You have to show that you can save something or earn something in order for them to start changing their way of doing things. And if you go on to make this kind of data-driven coordination or collaboration in value chain, you have to show that together you can save money on each year in order for them to get interest in the beginning. So that's how you start. You have to paint up, well, this is what you could do, but let's start on a smaller scale, for example, to reduce cassations or handle, instead of having reclamation and the argumentation of who is doing wrong when things fails in the value chain, let's solve it together. And from that, try to make savings. And when they start to realize that if I tell my customers that the paper has this functionality, it's not perfect everywhere, if I'm afraid that they will go to another supplier, well, then we have an issue. But if you instead address it like, well, let's solve this together, I'm telling you how the paper looks in more detail so that you can make the product better. That's a benefit for you. We can do this by becoming having a better relationship, a better collaboration. So the starting point is you have to have money in the background, and then the starting point would be, as we had before, to collaborate and start to talk about it and address it.
So, Mikael, can you come up here for a moment? Because and you should not walk away, you should walk this way. Because we have a couple of minutes left before we go into the Mentimeter that I hope you will all take part in. I'm just wondering, I mean, you have a lot of experience in this digitizing area or Industry 4.0 for the industry. How do you see the role of what Peter is representing, a pilot or test bed, so to speak? What is the role for that kind of environment in your bigger picture?
Yeah, I think we need a lot of, you say, proofs, way of proving that, yeah, this is right, this works, this doesn't. And I think that's very important to increase the speed to get to the sort of the end goals, if there is any. I mean, basically to get the speed up, we need to test this. And I think that's
and test
important.
Beds are like pilots.
And test beds is a good way of doing it, and pilots and also pilot plants like what you have here. I mean, it's a very good place to actually start doing this. And also to help a lot of companies making equipment for the industry to get to a point where they can start making smart equipment that they can then start selling.
And maybe also get inspiration on what is possible.
Yeah, exactly.
Because that's not easy to know if you...
Yeah, to showcase is just as important. To start in the sort of, well, in a good direction. Yeah.
And you showed one very interesting there with the copper. But that was real size, wasn't it? Yeah. It's an interesting world we're getting into. Tom, what do you think? Do you have any comments or?
Comment, yes.
Here, if you have a comment, please put it into the box.
You could say I'm a paper maker, but I realize that our paper making is very much computerized. But there is another platform, and that is from the forest to building materials, because the big thing in the future will be industrial building. And this is what we are interested in, a group of people. Because building, takes approximately between 55 and 63% of carbon emissions in the world, and very few, including Greta, they don't realize this. So what is happening, is basically hybridization, robotization, and digitalization in that end, so to say. This is what is going to happen. And for instance, if you go down to Southern Europe, you know, Middle Europe, I would say, to Switzerland, Germany, and Austria. You know, they are doing a lot of things here in this particular sector, like NCCR, you know, digital fabrication, etc. You know, the Gramazio laboratory at DTH. And so something must happen here. And I think that the Swedish forest products industry will start to realize this. Actually, we have been collaborating, talking to them for a long time. And they realized, ABB, for instance, you know, they have this Gramazio laboratory. It's a building site, you know, with ABB robots, you know. But, you know, they are, and we try to get a Eureka project with the Swedish wood technology people and ATH, you know. But they said, okay, prerequisite should be that you bring ABB into this because we have lost ABB. That's a challenge. It's different what you have. But I think it's a very important sector. Yeah. And I think that ABB should engage. I mean, ABB is here in Sweden, you know, and you have a lot to do in that specific area. Yeah. So
I knew you had a comment. I knew that. Suck it in. Okay. Okay. Thank you so much.
Tell you that the other people that are interested in this because we realize that this is a more important thing for the Swedish forest products.
Yeah. Great. So by that, Tom, I'd like to thank you both very much for your presentations. And you may sit down and bring out your smartphones because